So base, we know that base plus litmus gives blue in color. So that is extraction of red cabbage. I want to show you the image, you can understand clearly. So red cabbage, this is the red cabbage. So this is the red cabbage. So the extraction of this red cabbage, so also used as an indicator, but how it changes I will explain you. Actually red cabbage color is blue color, extract the color is, that means the liquid coming from the red cabbage color is purple. So purple color. And how it changes, so it is in acid, it gives in acid it gives blue, in base it gives red. So remember this one, it gives red. So it is somewhat different, red cabbage. And next one, turmeric solution. Third one is turmeric solution. So turmeric powder solution, if you take, how it is changes. So it is, we know turmeric powder, but in acid it doesn't gives any color. So acid doesn't gives no color, no color. In base it gives red. It is also somewhat different, you will remember. And extraction of colored petals. So third one, extraction of colored petals. You're going to take a paste of petals of some flowers, and we can use as a indicators. What are those examples are there? First one is hydrangea. So I'll show you the hydrangea plant. So I'll take the image, you can understand. So this is the hydrangea plant in basic soil. This is the hydrangea plant, and are you understanding this one? Are you seeing this one? So see, this is hydrangea plant. And then so second natural indicator petals, so what we are using is second one, petunia. So you'll see the image of petunia. This is petunia flower. So see, this is the petunia flower. Did you see? Next one, so third one will take geranium. So geranium plant also, petals also we're using, that I'll show you. So this is the geranium flower. So this is the geranium flower. So these are the natural petals we are using. Next one will go for synthetic indicators, that means man-made indicators. So next one, synthetic indicators. So these are also called man-made indicators, we can say. Two indicators mainly we can discuss. Those are, first one, methyl orange, methyl orange. So methyl orange actually orange in color, orange in color. So this is also important. So the color of the indicator they will ask you orange in color, you gonna say. But acidic medium, that means acid plus methyl orange, gives red color. And if you take base plus methyl orange, gives blue. So I'll change the color. So it is a yellow in color, yellow. So it's very important. So base plus methyl orange gives yellow color. So next one, second one, phenolphthalein indicator. Phenolphthalein indicator. So phenolphthalein indicator, actually the indicator color is colorless. So colorless, and the acid plus phenolphthalein indicator, so it gives colorless. So next one, I will take base plus phenolphthalein indicator, gives pink. So these two are very important: methyl orange, acidic medium red, basic medium yellow, and phenolphthalein, acidic medium colorless, basic medium pink. These two are very important. They are frequently asking in the exams. So next to, and ask you one of the question. That question is, so what is meant by antacid? What is meant by antacid? What it contains? What it contains. Antacid is a remedy for or medicine for acidity, that means gastric trouble. So answer is, so important question, important 2 marks question, and note down this one. So antacid, what we are using in market, Eno we are using, right? Antacid, so should not write separately. Antacid is a medicine for acidity. Second one, what it contains. So antacid contains first one, aluminum hydroxide, That means that it contains bases like so aluminum hydroxide AlOH thrice, and next one magnesium hydroxide MgOH twice. Why we're using bases? Why? Because in our stomach HCl is a releasing, HCl is a acid plus so baking soda, so or we can say hydroxides. So those are the bases. So neutralization takes place. In the sense, cools, stomach will cools. This is one of the question. Next, so we'll see. So phenolphthalein, any images we'll see to show. See, this is the turmeric powder. Once you see. So turmeric powder, they are adding lemon juice. Lemon juice is acid, no change. Turmeric powder, they are adding soap water. Then it is what color? Red color. You see? So this is red color. Next, another image you will see. So phenolphthalein indicator or methyl orange indicator. So images will see. So this is the image. So methyl orange, generally orange in color. It is seems to be red color, right? But it's orange in color. Acidic medium red, alkali medium yellow. Next we'll see phenolphthalein indicator. So we'll see phenolphthalein indicator now. So image we'll see. So where is that image? Yes, this is the image. So phenolphthalein indicator. So what color is showing? See. So acidic medium colorless, basic medium pink. Pink is shine. So this is one of the example for phenolphthalein indicators. Next to universal indicators. So we'll discuss about now universal indicators. Universal indicators. So universal indicators, I explained you before. Universal indicator, pH paper is a universal indicator. Paper. So methyl blue, thymol red, so bromothymol blue. So these are all universal indicators we can show. So I will show you the list. So the list I will show you. You can understand here clearly. So I will say once see. So indicators, acid, base. So indicators, first one, thymol blue. So thymol blue is an indicator which is in blue color. Acidic medium it gives red, basic medium it gives yellow. And next one, methyl orange. We know that methyl orange is in orange color. Methyl orange. So acidic medium it gives red, we know this. Basic medium it gives yellow, same. And third one, methyl red. So another one is methyl red, so it is somewhat red in color. Same result will give red, yellow. Next one, bromothymol blue. So fourth one, bromothymol blue. So it is somewhat different. In acidic medium it gives yellow, basic medium it gives blue. Basic medium it gives blue. Next thymol blue. So already thymol blue is this is second transfer. That means once after some times it turns into different colors. Thymol blue. Thymol blue. So it is second transition. What is meant by second transition? Means after some times, so the colors will be changed. First it gives this is the first transition. First it will gives red, after that yellow. After some times, second transition. This is called second transition. After some times, what color it gives? It gives yellow and blue. Blue it gives. So next one is sixth one. We know phenolphthalein indicator. Phenolphthalein indicator. We know what color it gives. Phenolphthalein indicator. So acidic medium, colorless. Basic medium, pink. So this is a universal indicator, and pH paper also universal indicator. We'll discuss now. Second one is pH paper. It is also universal indicator. Which indicates different colors. Now we'll see the image of this. So image I will show you. pH paper. See, this is pH indicator. Different pH values, it will give different colors. So did you understand this? Different colors it gives. This is pH paper. Next to chemical properties of acids and bases. We will discuss now chemical properties of acids and bases. So chemical properties of acids and bases. So to understand chemical properties of acids and bases, we will do one activity. So activity 1. So activity 1, we'll see activity 1. So activity 1, what are you going to do? All so indicators gives relevant colors. We know that all indicators gives, we can say, significant color. Significant colors. We know that. To perform that, we need to perform an experiment following the table. So this is the table. you can follow. So what this table, so you're gonna take two test tubes. In the two test tubes, one of the tubes you're gonna add acids. So the acid HCl is acid, H2SO4 is acid, HNO3 is acid, this is acid. Up to 4 you're gonna add, and another beaker or test tube you're gonna take NaOH, KOH, MgOH, and H4OH. This is what you're gonna add. So what is the change with color we gonna write? Now I'm writing here. So already we discussed, we can write now. So HCl is the acid, red litmus. So it no change. I'll keep blank. And blue litmus convert into red. So red. Next phenolphthalein indicator, acid, no color. So methyl orange. So methyl orange, it gives red. So H2SO4, you say, respond. You say. So H2SO4, same. Red litmus, no change. Blue litmus, turn into red. Phenolphthalein, no change. Methyl orange, red. Same. HNO3, same. Red. This is also same. Red. So base, red litmus turn into blue. So you're gonna take blue color, and blue litmus, no change. Phenolphthalein indicator, it gives pink. And methyl orange indicator, it gives yellow. So now same for all, right? Same for all. KOH, blue, and it is pink, it is yellow. So blue, no color, pink, yellow. Blue, no color, pink, yellow. Blue, no color, pink, yellow. So this is the table color. This is the first activity you're gonna remember. To remember all the color changes accurately, that activity you're gonna do. Second one, activity 2. Activity 2, what are you gonna do? So activity 2, chemical test for acids. So we can say this one, chemical test for acids. So what test you're gonna do? So you're gonna take a test tube. So we'll see first. So one of the image, then I can explain you clearly. So this is the image. See, this is the image. So see here, test tube you're gonna take. In the test tube, HCl you're gonna pour, zinc granules you're gonna take. So I will enlarge this. You can understand or see clearly. See, so this is the apparatus you're gonna make, and so once you see this and try to understand what I'm explaining. So take one test tube, and drop, you can write, not pour, drop zinc metal granules and add HCl mm, orange shown in the figure. So test tube we're gonna add, test tube we're gonna take, in the test tube zinc granules you're gonna take HCl and see, so we'll highlight HCl you're gonna take, HCl you're gonna pour. So one whole rubber stabber you're gonna take, delivery tube you're gonna take. Okay, total equipment you're gonna fix to the stand. So what you're gonna take now? So after some times there is a chemical reaction between acid, HCl and metal. So one of the gas is released. We're gonna test for that gas. So in the downward displacement of water, we're gonna bubble the gas, and then if you keep burning splitter near the HCl, so it will gives pop sound. So didn't write here, I will write here. It gives what sound? Pop sound. Pop sound is very important. Pop sound. It will pop sound will gives. That is the test for the released gas is H2. So H2. So what conclusion you can make? So any metal reacts with acid, HCl is present, HCl is released. So that is the chemical. So test for acid. What is the test? So any acid reacts with metal, release hydrogen gas. So this is the test for acid. And what is the test for hydrogen gas? So the test for hydrogen gas. So test for hydrogen gas. So what you're gonna take? You're gonna keep burning splitter near gas valve. So it will use pop sound. Gives what sound? Pop sound. So understand, this pop sound is very important. So this is the activity 2 and activity 3. You can see activity 3. Third activity. Activity 3. So in activity 3, what are you gonna take? You can, so we will see the test for the same test with base. So that means if in the base, if you drop metals, what will happen? In base, if you drop metal, here what we took, zinc, same zinc I am taking, metal, no reaction, there is no reaction. But if you warm it, again it releases, so H2 gas, release H2 gas. That means what we can say, so in acids, if you drop zinc metal, immediately release hydrogen gas. So but in base, so if you drop metal, so it won't immediately gives H2 gas. If you warm it, then only it will use H2 gas. Now we'll write the chemical reactions. So I am taking chemical reactions. See here. So I will write the chemical reactions. Acid, so I will write like this. I will write like this. See once. HCl plus zinc granules. If you drop, salt is formed plus H2 gas is released. Whenever you add sodium, so no reaction. The same sodium, if you warm, then what will write? Na2. So what will use? Zn2. So Na2 Zn2 plus H2 gas is released. So this is the difference. You can remember this one. So we will see activity 4. So activity 4. What activity 4 says? So there is an image, you can take image, then you can understand easily. So this is the image you can take. So this is the image. So I will make it small. So this is the image. What are you going to take? So sodium carbonate you're going to take, and HCl you're going to drop. Sodium carbonate solution you're going to take, HCl you're going to drop. Sodium carbonate, actually it is in a solid state, we can take solid, and HCl you drop. What you will see, it will release CO2 gas and CO2 gas. In another beaker we're going to take calcium hydroxide. So CO2 is calcium hydroxide turn into milky. That's what I explained you before. I explain you now. You can understand clearly once you see. SEMA. So sodium carbonate Na2CO3 you're gonna take in the granules solid, you're gonna take in the test tube, and then you're gonna add HCl acid. What will happen? Na reacts with Cl, NaCl is formed, plus water is formed, plus CO2 is formed to neutralize or to balance the reaction. So CO2 is produced. If you take sodium bicarbonate, same HCl you drop, same NaCl plus H2O. So H2O plus CO2 is produced. When CO2 is produced, how can you test CO2? You see here, to test the CO2, we took lime water, CaOH twice, lime water we took. We bubble the CO2 gas in this. We bubble the CO2 gas here. Then what will convert? Test for carbon dioxide. Whether released gas is carbon dioxide or not, how can you test? So test for CO2. This is very important. Test for CO2. How can you test? That we can say lime water. So what is in the solution? What is in the small test tube? That is lime water. Small test tube, lime water. So you're gonna take lime water, turns milky. That is the test. So lime water in the sense, what is the lime water? CaOH twice we saw in the small test tube. This is lime water in the small test tube. So lime water plus CO2 gives CaCO3 plus H2O. This is precipitate. So simply you can call as a PPT. It will form like a precipitate. It will float on the surface and it will appear like a milk. That's why it is called milky. And next to excess, if you pass, so CaCO3, if you pass excess, it will react with the CaCO3 and what will happen? It will dissolve. What will forms CaHCO3 taken twice, soluble in water. This is test. And what we conclusion. So what we conclude? We can conclude that metal carbonates, or we can say, I will write here. What we conclude? Metal carbonates, metal bicarbonates reacts with acid gives salt plus water. Important is along with that CO2 is released. This is the conclusion. We will stop our class here. Next class we will discuss this video is so long, up to 50 minutes, you see. So next class I will ask you some of the questions, you can answer, right?